why do we hear echoes? Hey, hold on. Don't go into that room. You don't want to listen to me. Okay, then go ahead. See, I warned you. Will you listen to me now? Don't worry. The sound you heard was just an echo of your voice. Let me explain what an echo is. When we speak or laugh in a big empty hall, we hear our own sound repeatedly. This is because our sound waves get reflected from the walls of the hall back to us. The reflected sound that we hear is called an echo. Hence, an echo is defined as the repetition of sound caused by the reflection of sound waves from a hard surface back to the listener. Hey, what are you doing? Are you trying to hear an echo? It is not that easy. There are two ideal conditions for an echo to be heard. When we speak or laugh, we hear our original sound at that moment. The sensation of this original sound remains in our brain till 0.1 seconds. This time is called the persistence of hearing. When we utter sounds, some of our sound waves get reflected while some get absorbed. If the reflected sound waves reach our ears before the completion of 0.1 seconds, then our brain does not perceive the original and reflected sounds as separate sounds. They are interpreted as one sound. Therefore, in order to hear two distinct sounds or an echo, the time gap between the original sound and the reflected sound or echo should be at least 0.1 seconds. This is the first condition for an echo to be heard. Do you know when the time gap will be more than 0.1 seconds? This gets us to the second condition for an echo. The minimum distance between the speaker and the reflecting surface should be at least 17.2 meters. When the distance is 17.2 meters and we start speaking, assume that the original sound reaches our ears at this time and the reflected sound reaches our ears at this time, then the time interval between the reflected sound and the original sound will be equal to 0.1 seconds. As a result, we will be able to hear an echo. Alright, now let us try and hear an echo in this room. It is even bigger than the previous room. Now, why can't we hear an echo? This is because there are many soft furnishings like sofas, carpets, curtains, etc. in this room. They absorb most of the sound waves. As the sound waves do not get reflected, we are not able to hear an echo in this room. Hence, one more thing to consider if we want to hear an echo is that there should be minimal use of such sound-absorbing materials. Hooray! Why is a bag of chips half full? Looks like you don't believe me. Open the bag. See, I told you. The bag of chips is indeed half full. Why is that so? It is mainly because of a concept called rancidity. When food becomes rancid, it develops an unpleasant smell and taste and it becomes unsafe for consumption. Rancidity generally refers to a condition where the fats and oils present in food get oxidized, resulting in food spoilage. Since the chips contain fats and oils, they are likely to get rancid. Therefore, to prevent this, nitrogen gas is flushed into bags of chips by manufacturers. But why nitrogen? Nitrogen does not react with fats and oils. As a result, rancidity does not take place. Moreover, a gas in the bag serves as a cushioning agent and prevents the chips from crumbling. That is why the bag of chips is only filled till half. Did you hear Yanny or Laurel?
Laurel. Laurel.
I hear Yanny.
but some people hear laurel.
But why, dude?
Wait, I'll explain. A sound comprises of several frequencies. However, some people have a greater sensitivity to higher frequencies in a sound, while others have a greater sensitivity to lower frequencies.
I have a greater sensitivity towards chocolates.
Please listen. In this audio clip, the higher frequency forms the sound yanny and the lower frequency forms laurel. So, if you have a greater sensitivity to higher frequencies, then you will probably hear yanny. Whereas, if you have a greater sensitivity to lower frequencies, then you might hear laurel. In addition to this, age could also affect the frequencies we hear. This is because as we age, we begin to lose our ability to perceive higher frequencies. Hence, older people tend to hear laurel while younger people hear yanny. What causes sinkholes?
Maybe water.
This time, you are absolutely correct.
Yippee!
A sinkhole is a depression or cavity in the ground which is caused by water erosion. Water erosion is a naturally occurring process in which water wears off soil and rocks.
Wow, water is so powerful.
Indeed. Now listen. The upper layers of the soil comprise of sand, clay, etc., while the bottommost layer, called bedrock, has rocks. Generally, sinkholes form in places where the bedrock layer has rocks made up of limestone or dolomite. When rain falls, it seeps into the soil, reaching the bedrock. Over time, the water dissolves these rocks and thus erodes them, forming hollow cavities. As these cavities get bigger, the ceiling of the cavity, that is, the upper layers of soil, cannot hold the weight. Hence, they collapse, forming sinkholes. What causes kidney stones?
Swallowing a stone?
No. Our kidneys filter blood by removing waste from it in the form of urine. Urine consists of water, urea, uric acid, and ions like calcium, sodium, oxalate, and potassium. However, when some of these constituents such as uric acid, calcium, and oxalate ions increase in the urine, they bond together, forming kidney stones or renal calculi. One of the most common kidney stones is calcium oxalate.
So can I use it to build my house?
Oh, just listen. Generally, the kidney stones are small. Hence, they pass unnoticed through the urinary tract. However, sometimes these stones become so big that they start to scratch walls of the urinary tract and may block the path of the urine, thus causing immense pain. Archimedes' principle. Why do we weigh less in water? Hey, looks like you have gained a lot of weight. Come on, let us check your weight. You weigh 132 pounds. All right, don't get stressed. Check your weight in water. Look, it is much lesser. Do you know why you weighed less in water? The answer to this is based on Archimedes' principle. Not that principle. Archimedes' principle is a fundamental truth which states that an object fully or partly immersed in a fluid experiences an upward force called buoyant force, which is equal to the weight of the fluid displaced by it. It went over your head, right? No worries. Let me explain. Downwards, whether we are on ground or in water. However, according to Archimedes' principle, when we are in water, we experience an upward force. That is, buoyant force, which is equal to the weight of water displaced by us. This upward force cancels a portion of our weight, causing us to weigh less in water. Respiration. Why is it not good to sleep under a tree at night? Hey, you look so tired. Why don't you take rest here? Hooray! Now, please don't sleep under that tree. It is quite harmful. See, you are not able to breathe properly, right? Do you know why? Wait, I will tell you. This is because during the day, in the presence of sunlight, plants take in carbon dioxide and release oxygen in the process of photosynthesis. However, they even respire simultaneously. In this process, plants take in oxygen and release carbon dioxide. But the production of oxygen is more than the production of carbon dioxide. Hence, if we sleep under a tree during daytime, we may get a good amount of oxygen, thus giving us a nice sleep. However, at night, plants do not perform photosynthesis due to the absence of sunlight. But respiration still goes on. Hence, as compared to oxygen, the proportion of carbon dioxide around the trees is more. Thus, if we sleep under a tree at night, we may feel suffocated due to lack of oxygen. Moreover, inhalation of excess carbon dioxide is harmful to human beings. Therefore, it is not good to sleep under a tree at night. Why does hot air balloon float?
'Cause it has invisible wings.
No, it is because of density. Density is the measure of mass present per unit volume. Lesser the density, lighter will be the object. Now, density varies with temperature.
Oh, dude, it is so complicated.
All right, I'll explain. When a hot air balloon is on ground, the air inside and outside the balloon is of same temperature and density. However, when we turn on the burner of the balloon, the air inside the balloon starts getting hot. The molecules of air move faster and spread apart, taking up more space. Hence, the air inside the balloon becomes less dense than the air outside. As less dense air is lighter, the hot air balloon rises and thus begins to float. Heat transfer. Why are cloudy nights warmer than clear nights? Hey, look at the weather outside. It is too cloudy. No, don't go near that bonfire. It is going to be warm tonight. You don't want to listen to me, right? All right, go ahead. Look, I told you. At least now will you listen to me? During the day, our Earth receives light from the sun and gets heated. Now, during a clear night, that is, when there are no clouds, this heat easily escapes through the atmosphere into space, resulting in cooling of the Earth. Now, to understand what happens on a cloudy night, let us heat the Earth once again. In this case, the clouds act like a blanket, preventing the heat from escaping into space. Since the heat remains in the atmosphere, cloudy nights are warmer than clear nights.